I can, gang, gang. Hey, gang, gang. Ooh, yeah. Yes, I can, 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 yes, I can. Ooh, yeah. Og dog, pull up in a white van. Yeah. Hey, slide dog, you know you a hype man. Yes, I can, 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 yes, I can. Ay, can't see Ogden as he run past. Coach Matt been serving up the good fraps.
Shake Ogden's hand as I walk in the class, turning my horn phone and so my past. Start up my warm up because I'm succeed. I get the thing done and I do them at D. Grabbing these points and I'm making it right. I'm saying hello, I'm catching these flights. If nobody's nappy, the class will be happy. And nobody making a friend. Okay, class, one more time. Kiss the colonel and raise your hand if you are sitting down. Yeah, just give me 20 on 3. Come on, let's see who the best class is going to be.
Welcome to KYIC News, Channel 17, Season 1, Episode 5. Youngsters, thanks for joining us today, because I know some of you may have pulled the ripcord, but I appreciate those who are here. And the first order of business is a shout out to all the mothers out there. Now, I know it was yesterday, so if you have not appreciated your mother, stop this tape right now, pause it, and go make lunch for your mother. Stop it and go make lunch for your mother. Okay. In particular, I want to thank two mothers. Of course, my wife, the mother of our 3 kids, and my mother. I'm 133. You can imagine how old she is. God bless her. So, on that note, let's go quote of the week. The quote of the week today is this. When you are grateful, fear disappears and abundance appears. Anyone know who said? Andrea. Way to go, Andrea. Anthony Robbins. We need to be thankful, have an attitude of gratitude. Things are looking up. The beaches are open, some restaurants open next week, but maybe some other stores are open. So let's be grateful for what we have. Hey, on that note, I'm sad. You want to know why I'm sad? I've had office hours Tuesday and Thursday, 12 to 1, and the last week and a half, it's been painful. No one's showing up. Now, I know some of you may have pulled the ripcord, but now's not the time to give up, people. Come in, say hi, ask me a math question, just fake it. Because this is what I've been going through. I want to tell you, it's not pretty. Let me show you the tape. Hello? Hello, anyone there? How is somebody? Hey people, for a phone call a week, you can save that poor guy from absolute boredom. Hey, on the birthday front, I got to tell you, I got to share some birthdays this week. Let me give you some names. Ryan Chestnut, happy birthday. Cameron, happy birthday. Meadow, happy birthday. Sasha, Maddie, Sophie, and Jake. This is for you people. Everyone, let's sing along. Hit it! Happy, happy birthday from the birthday gang. Hope you had a good day. So happy, happy birthday from the birthday. If you see those people on the street, at the beach, give them a high five. Maybe just give them an air high five. All right. Hey, speaking of beach, have you seen our weather lately, people? Have you been outside? It is fantastic. Let's go. And we have a special report this week from someplace special. Check this out. Let's go to the weather. Alrighty, thank you, Sir Dog. Look at this fantastic weather this week in Carlsbad, California. It doesn't get any better than this. We thought we'd do our weather report from the beach today, since it's so nice. And as you guys know, the beach is open, so we're allowed to walk, and we're allowed to look at the ocean. We're allowed to go running.
Sir, you have to keep moving, unless you're doing algebra.
I have to keep moving, unless I'm doing algebra. Well, in that case, I'm going to stop and do my home fun, people. I suggest you do the same. Back to you at the desk, dog. Wow. Is it great weather right now or what? Well, that was a great weather report. So it sounds like you can sit there on the beach and do some algebra if you like. That's what I'll be doing later. Okay, hey, I got some great sports news. I don't know if you guys heard or not, but some sports activities are happening. I think we should go to the sports desk and find out what's happening. Hey, thank you, Sir Ogden. You're doing a great job on the desk this week, as always. Hey, we have a lot of sports going on this week. If you guys have not heard, behind me right here is Korean baseball. It is back. This is a live game from Korea. Isn't that exciting? You know what that means? We're probably weeks away from Major League Baseball. So that's exciting. Now, if you're not a big fan of Korean baseball, then we got something else going on at the Ogden house. Let me show you what we're doing thanks to our friends from Dude Perfect. Hey, good night, everybody. Wow, that sounds like fun, doesn't it? Now, hey, the reason why we're here, we got some important algebra news for those people who are still with us. Again, I appreciate it, and I do appreciate those students who are hanging tough, doing their home fun, getting it in, and want to finish strong in the next 5 weeks. Believe me, you will not regret it. Let's go to the algebra desk and find out what's happened this week. Hey, in the world of Algebra 2 this week, we have some good news. We have our last topic of Module 16. So for those of you who are still with me, I appreciate you tuning in this week and getting that brain to be a little bit stronger and a little bit bigger, and I think you'll be better for it down in the long run. So what we got this week is solving exponential equations. As you recall last week, we solved logarithmic equations. And judging by what came in, most of you had a pretty good idea what we were doing. So today, we're solving logarithmic equations. And you'll be wondering, what is that all about? Let me help you out. You're thinking, what does Meghan Trainor have to do with solving exponential equations? Well, let me tell you, people, we have two types. The first one is about the same base. It's all about that base, Let me give you an example. Okay, example number 1 is all about that base. Thank you, Meghan. Okay, it's all about that base, people. If you have two numbers on each side of the equation, and you can figure out how to change them to the same base, that's example number 1. Let's change 4 to a base of 2. Anyone have an idea how we can change 4 to a base of 2? Hey, Seuss, what do you think? Way to go, Jesus. Let's change 4 to a base of 2. 2 to what power equals 4? I believe it's 2. So we have 2 squared raised to the x plus 1. That's going to equal 2 to the 3x. So far, so good? Now, as you know, what can we do with a power raised to a power? We multiply. Let's distribute that 2 to the x plus 1. So we have 2 to the 2x plus 2 is equal to 2 to the 3x. So far, so good?
That was easy.
Of course it was. So now, if I have the same base, it's all about that base. Can I just cross those bases out? Set the exponents equal to each other, and away we go. So now I have 3x equals 2x plus 2. Can we solve that? Yes, we can. Minus 2x on both sides. And I get x is equal to 2. Congratulations, people. You just solved your first exponential equation. Let's go to example number 2. Okay, thank you, Megan. Example number 2, not 1. but 2. It's about that base. Here we go. We have a 3 and we have 27. Is there any way we could change 27 to a base of 3? Aspen, what do you think?
Yes.
Way to go, Aspen. Let's change 27 to a base of 3. 3 to what power equals 27? I believe it's 3. And raise that to the 2x equals 3 to the x minus 7. What do you do with the power raised to a power? Of course, we multiply. So we have 3. 3 times 2x is 6x equals 3 to the x minus 7. Here's the best part. We have the same base. Because as Meghan Trainor says, it's all about the base. Let's cancel the bases. And we get x minus 7 is equal to 6x. Let's minus x on both sides. Everybody, backwards. We get negative 7 is equal to 5x. Divide by 5, and we get negative 7 over 5. Cha-ching, bada-ba-bing. Okay, now for type number 2 for solving exponential equations, we need a little help from our friends at Madagascar. You're probably thinking, Mr. Ogden, what does Madagascar have to do with solving exponentials? Well, let me show you. Log it, log it. Log it, log it. Log it! Log it! So in this case, you may notice that we cannot change the base 15 to a base of 2. So the bases will never be the same. So in this situation, we have to log it, log it. Log it, log it. Here we go. What can we do to get this exponent down to here? What if we log base 2 on that side? If we do something to one side, we got to do it to the other side. So we have log base 2. Now, if you recall, a couple weeks ago, we talked about the properties of logs. The property tells me I can take this x, the power, and move it to the front and make it a multiplication factor. So what is log base 2 of 2 equal, though? If you guys remember a couple weeks ago, our properties tell us log base 2 of 2 is equal to 1. So we end up with x equals, what's log base 2 of 15? Log base 2 of 15, I believe, is 3.907. Cha-ching. Bada-ba-bing. Log it, log it. Let that simmer for a second. You might want to play it back and go from there. So whatever that base is, you have to log that base on both sides. They cancel. You're left with x equals 3.907. What do you think? Very good. Log it, log it. Log it, log it. Log it! Okay, example number 2. Now, this is a mess. And you notice we have an e in there. So that could change things a little bit. But the first thing we got to do is isolate that base. We got to isolate that e. What's my first step? We want to get rid of that 4. That's minus 4 on both sides. Everybody? We get negative 2e to the x is equal to negative 27. How do I get rid of that negative 2? Let's divide both sides by negative 2. I end up with e to the x is equal to 13.5. Now, the last example you recall, that was a number 2. This is a letter E. Do we know of a log with a base E? Yes, we do.
Well, yes.
It is natural log. So let's go natural log on both sides because my natural log has a base of E, and they will cancel. If I log one side, I got to log the other side. Natural log base E. Log it, log it. What happens here? Take the x, cancel that. You get x is going to equal the natural log of 13.5, which I happen to know in my head is 2.603. Now, if you don't know it in your head, just put it in a calculator. Natural log of 13.5. Cha-ching, bada-ba-bing. Good job, people. Play that back and make sure you get it. Log it! Okay, our last example today, Yiksters, is a life problem, aka word problem. And it's going to go something like this. We have Yicktown. It's a coastal town near Carlsbad. It has about 3,400 people. It's going to grow at about 3% a year. So we're going to use the growth model that we learned, I think it was about a week ago. It looks like this. Y equals A, 1 plus R to the T. In fact, I think we talked about that before the pandemic. Y is the ending value. A is the initial value. R is the rate of growth. And T is time. That's called the growth model. How long will it take to reach 10,000 Yiksters in this town if the population grows at 3% a year? So that's our problem. Let's see if we can figure it out. And I'm thinking we can. Okay, here we go. Okay, we have our growth model. We have Y is going to equal the ending value. What we're looking for is 10,000. A is my initial value, which is 3,400 people. My R is my rate in decimal form. Make sure you change to decimal, 0.03. And I'm looking for time. How long will it take the population of Yicktown to go from 3,400 to 10,000? Let's solve for T. What's my first step? Let's get rid of that 3,400. Divide both sides by 3,400. Everybody? What's 10,000 divided by 3,400? Well, I believe it's 2.941 is equal to, let's combine those and get 1.03 raised to the T. Does this look familiar?
Yes.
Yes, it does. What do you think, TJ, I should do next? We have to log it, log it. We get to log it, log it. Way to go, TJ.
Yes.
What log am I going to use on both sides? What base am I going to use to get rid of that 1.03? I'm thinking 1.03 on both sides. Log it, log it. Those will cancel. I end up with T is equal to approximately 36, just put that in a calculator, 36.5 years. Now, if you recall, some of you may be confused, how do I put that in a calculator? You have to use the change of base formula, which is what we talked about last couple weeks. You can go log 2.941 divided by log 1.03. Boom, you get 36.5 years. Does that make sense? Yeah. I think it does. Way to go, people. Give yourself a woo-woo. You know why we feel good, people? Because that was our last example of solving exponential equations. So, you will have a worksheet, a handout in Google Classroom, and maybe some more practice. Make sure you do that first. And then there's going to be a little quiz after you know what you're doing. So make sure you feel good about it before you tackle that quiz. You're only going to get one shot at the quiz this time. So feel good about that. Make sure you know what you're doing. Continue that growth mindset. And let's go back to the desk and make it a great week. Log it!
That was easy.
I hope you think that's easy, people. And remember, you college algebra, Yiksters, got a quiz this week, so make sure you're prepared. Hey, a couple reminders as we wrap things up on the KYIC news. We have timetables this week are important. You got to make sure you get stuff in on time. The quiz for college algebra, we have a short window between Thursday and Saturday. Make sure you get that in because we won't be doing any open windows later. Just a reminder, quizzes are 60% of your grade the final 6 weeks, and home fun is 40%. So keep that in mind. Now, the number 5 question of the day, in honor of our mothers. Here we go, people. If a mother is 5 times as old as her son, in 15 years, she will be only twice as old. How old is the mother now? You can play that back if you'd like to hear it again. But how old is the mother now? First one to get that into me, you know what. Okay, on that note, I want to thank you for being here this week. Finish strong. Join me in office hours if you have questions. Carlsbad. Show an attitude of gratitude and make it a Yes I Can week.
Yes I can, 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 yes I can. Can't see Ogden as he run past. Coach Matt been serving up the good fast.
Shake Ogden's hand as I walk in the class, turning my home phone and so in my past. Start up my warm up because I'm succeed. I get the thing done and I do them at D. Graphing these points and I'm making it right. I'm saying aloha, I'm catching these flights. If nobody's nappy, the class will be happy. And nobody making a frown. Okay, class, one more time. Kiss the colonel and raise your hand if you are sitting down. Yeah, just give me 20 on 3. Come on, let's see who the best class is going to be. Mysterious values, I find them so nicely. Ogden gets sassy, he getting too feisty. Ogden says square up, he wanna go fight me. Probability, I fight him most likely. Drive by the class in my new